once the analysis has finished running, we are left with two log files that were created by the monitors we specified in the analysis. So the first log file, as you remember, was created by the monitor model, which monitored all the numerical values for parameters that went into the model. And then we had a monitor specifically for the tree topology. Now, the first thing to check when looking at the results of an MCMC analysis is whether it has converged, meaning whether we have reached the stationary distribution and sampled from it. And a good way to look at this is to load the log file into a software such as Tracer, which is shown here. Now, on the left-hand side of the software, we can see a list of all the parameters that were logged in that file. And we can see for each of them the average value that was sampled, and we can see the effective sample size, or ESS. Now, this ESS is very important because it is what indicates convergence and good mixing of the corresponding parameter. You can see here that Tracer will flag values that are below 200, it will flag in yellow values that are between 100 and 200, and it will flag in red values that are below 100, which are considered really bad. Now we can see that there is a mix of ESS value in this particular log file. Some of them have mixed particularly well. For instance, the parameters that are associated with the morphological evolution model on the whole have mixed pretty well, whereas some parameters like the origin time or some of the fossil ages, so T of 1 in particular and then T9, T10, have mixed pretty badly. Now, this can be an indication that the tree topology, for instance, has not mixed very well and hasn't converged. So that would be something to look out for. Now, one way to solve that issue would be to simply run the analysis for longer, because that would allow you more time to reach convergence. Another way to solve this issue is if you see that some parameters mix very well whereas some don't, you can go back to your analysis and modify the weights of the moves so that you increase the weights of moves that operate on the parameters that didn't mix, and you can in turn lower the weights on the parameters that did mix. So that can be a good way to not increase the computational load of your analysis too much, but still obtain like good mixing across the board. Now, assuming that you are satisfied with the convergence of your analysis, the next step you may want to look at is getting a summary tree from your tree distribution. Now, we have saved the tree topology, branch times, and fossil ages to our file output bears trees, and we can load that into the ref-based terminal, so we don't need to include that as part of the script because this is a very simple command. So this will create a trace object that will just be the tree distribution that was read from the file. And this can take a little bit of time depending on the length of the file. By default, there is a burn-in of 25% that is used when reading the tree trace. And one important thing to note is that this is different from Tracer, which uses a burn-in of 10%. So if you're trying to make correspondence between the log file and the tree file, you have to pay attention that you should probably use the same burn-in value for both. And then we can use the MCC tree function to create a maximum clade credibility tree from our tree file. And so we just call that using the trace that we just created above and giving it a file name where to store that MCC tree. There are many options to look at this MCC tree and look at how the topology is arranged, where the fossils are placed, and so on and so forth. In this tutorial, we use a browser-based tree visualization tool that's called ICTree. It can be accessed as this URL, https://ictree.org. It has many different options to visualize different things on the tree, so we encourage you to play with it and see if you can find a visualization that you like or that shows the information that you want to see. And we have added a few things in a few questions in this tutorial that you might try to look at in IC3, see if you can figure out the answers. And so this is an example of one of the figures you can obtain from IC3 showing the MCC tree.